Hey guys, welcome to another one. Today we're going to be flying through exam objective 2.4, explain common network configuration concepts. We're going to be flying through this. By the end of this, I'm going to make sure that you are 100% going to pass your exam. No doubts, no ifs, no buts about it. I'm going to tell you everything you need to know. I'm going to give you every kind of question you might be asked on your exam. I'll tell you what they might actually ask you so you're ready when you go in there, and I'm going to give you some practice questions so that you can actually see if you've learned what we are here to learn today. So today we're looking at explaining common networking configuration concepts. Specifically, we're looking at a whole bunch of different DNS specifics of DNS and the different things that are within DNS, the different types of records that you can have there. We're looking at some specifics in relation to DHCP. We're looking at some specifics about these here, which are new. We're going to talk about those, what they mean, make sure you know everything you need to know. And then finally, we're going to have a look at some virtual LANs and a VPN, which I'm sure we've all heard of before. So I'll put my glasses on and I'm going to get ready to take you through this as quickly and efficiently as I possibly can while still making sure you know everything you need to know. So we should hopefully know what a DNS server does by now. It translates URL names that humans read, right? It translates these into IP addresses and vice versa. So if you type in example.com, the DNS server is responsible for saying, oh, wait a second, they actually mean this IP address. I can take them there. Or alternatively, you can look up, I want to know what the domain for this IP address is, and the DNS server will say, oh, let me just look that up. Oh, it's example.com or journeytocyber.com if you want to get your free practice exams, for example. All right, now we should know that. I'm not going to spend too much more time on that. We should have that by now. The A record is the first one you need to know about. It's a specific type of record within the DNS server. It's explicitly mentioned on your exam. You need to know that an A record essentially is mapping an IP address, an IPv4 address, right? Because we have IPv4 and IPv6. An A record maps an IPv4 address to a domain, okay? So theoretically, if you wanted to go to this domain, you would type that domain in, and an A record here would map that domain to an IPv4 address, which is just this one here. Remember, IPv4 is the one you're most likely, most often going to be asked about on your exam, is 192.0.2.1, or anything with 4 digits separated by those dots, okay? So that's an A record. That's pretty much it, guys. AAAA, or quadruple A record, it's the same thing, but instead of for IPv4, it's for IPv6. All right, so it would have a look at an IPv6 address, which would look something like that, and it will translate between that and a domain name. That's pretty much it, guys. 1A is IPv4. 4A's is IPv6. That's what you need to know, all right? Next one is canonical name or CNAME. What this does is it's basically, what it's doing over here is it's saying, okay, you know what? This website, which I highly recommend you visit, is the same as this website. So if someone searches for this website, you can take them to this website, right? They're the same thing. It's saying this URL address, this name also means this name. So that way, you'll be able to know that you can safely store like one website, for example, under multiple different domain names, all right? Because you can do that, and you can just put in a CNAME entry into the DNS, and you can say, look, these are the same, Journey to Cyber equals getthebestresultsavailable.com. They're the same thing. If anyone searches either one of those things, take them to the same address, to the same IP address, which is here. Now, mail exchanger records. Pretty self-explanatory. It's going to be about mail, right? So it directs mail to the mail servers for a domain. It also specifies the priority of mail servers if multiple servers are listed. So first try to send it to this one, and then if that doesn't work for whatever reason, try to send it to this one, etc. Okay, that one's pretty self-explanatory too. Then you've got text. This is where we're really going to focus in on a couple of them, all right? Some specific ones. So a text record in DNS is used to store text information. It can hold arbitrary text data and is often used for various purposes such as domain verification and security policies. So you can use a text entry for a wide variety of things, right? Really, truly a wide variety of different things. We're going to have a look at some specifics that you can use, and that we're going to be looking at how you are going to need to know that you can use for your exam as well. A text record can contain one or more strings of text. If you're looking at a line of just text, that's generally referred to as a string. It can be used for domain verification. It can be used for email security. And that's what we're really going to dial in on now. But so far, just know a text record, you can store arbitrary text data, right? Any kind of notes or anything like that, you can store that in text. But what you need to know is they can largely, and this is specified on your exam, be used for spam management. So text records can be used for spam management. Remember in the last couple of videos, we looked at this kind of image where you've got all this mail you do want in your inbox, but people are trying to send you spam as well. All right, you can use text records in a DNS server to help with spam management. And there's 3 different types that you need to know about. All right, so we've got 1, 2, 3. We're going to have a look at each of them. The first one, text record that you can use in DNS to help with spam management, is called Sender Policy Framework. All right, so basically what this does is it has a look at which IP addresses are actually allowed to send mail on behalf of a particular domain. So for example, if you have this mail come in, the SPF text record can actually go in and it's going to say, hey, I actually can have a look at which servers have the permission, which servers should really be sending mail on behalf of this person. Okay, and if it matches this or this, these are allowed. So yes, I'll accept it. But if it doesn't match that, that means it's probably spam and I'm going to get rid of it. Long story short, that's what it does. Okay, that's SPF. You can pause and read the notes here, but I'm going to try to keep the video moving on. So please pause and read if you want to know, but I gave you a pretty good rundown just there of roughly what you need to know. We're going to move on to the next one, which is domain keys identified mail, otherwise known as DKIM or DKIM, I guess, as you may say. Now, basically, we'll go with the visual representation first. What happens here is the individual is sending mail, right? What they do is they create a private key and they create a public key, all right, as a text record in their DNS server. Now, what they do is they actually use the private key to sign the header of their email, and they release the public key in their DNS server. Okay, that is released as a public text record. So that way, what the recipient of that mail can do is they can say, okay, hold on, I've just received this email and it's been signed with the private key. What I'm going to do is check with the public key to make sure that everything matches up. And if everything's good, sweet. But if there's any differences there, then I'm going to say that's probably spam and I'm not going to accept that. So long story short, for your exam, what you need to know is that domain keys identified mail, or DKIM, involves the creation of 2 different keys, one private and one public, in order to sign the mail with a type of signature, right? With the private key, the sender signs with a private key and releases a public key. And if they don't match up, it's considered spam, essentially. So basically, guys, you can have a pause and a specific read of how that works here. I don't want to talk through it because I want to keep these videos moving on relatively quickly, but pause and have a look if you want to, okay? All the information you need is right there. I'm going to move on to the next one, which is domain-based message authentication reporting and conformance, which is a lot, but it's basically DMARC or DMARC. Okay, so DMARC or DMARC, how that works is it's essentially, in my mind, I think of this guy called Mark. He's kind of nerdy. He's got glasses on. He doesn't really do the grunt work. But what he does is he's got his 2 bouncers, his 2 muscle guys, right? They come in and they're like, hey, boss, we got this spam mail. We talked about the SPF function and we talked about the DKIM function before. I just told you about those 2. They will perform these tests on the mail to see if it's spam or not. Based on that, they'll take it to MARC, or Domain-Based Message Authentication Reporting and Conformance, DMARC. They'll take it to MARC, and MARC will tell them what to do with it. So MARC sets the policies for if an email fails these tests, this is what we should do with that email. All right, long story short, that is what DMARC is. Again, you can pause and have a read here if you want to read the specifics, but I'm sure you don't want me to read all that out to you. It's there to pause and read if you want. All right, I want to get to those practice questions quickly. All right, so the main differences here that you need to have a look at is DKIM proves the email is really from the person it says it is from and it hasn't been messed with. The signature is checked using a key stored in a text record on a DNS server. All right, that's the DKIM. DKIM. SPF is like imagining a guest list for a party. SPF is a list of who's allowed to send emails from your domain and who isn't. And they check to see if it matches or not. And if it doesn't match, it's considered spam. DMARC is like the bouncer who decides what you actually do with that information. If someone isn't on the guest list, where do you put them? Do you throw them in the basement? Do you send them to the police station? What do you do, right? So you might have to watch over that again if it's a little confusing. Don't worry about it. It took me a bit to get my head around, but we'll get there, right? I'm going to move on. Pause and read that. Rewind and read and listen again if you need to. And I'm going to keep this moving because I want to get you guys there sooner rather than later. Now we're on DHCP. So we've talked about DHCP before. By now we should know that DHCP servers are what is responsible for when a new device joins a network, they give that device an IP address. All right. They go through something, and this is new, and they may very well ask you this specifically on your exam. They go through something called the DORA checklist. I'll just get a nice thick one here. They go through something called not the checklist, sorry, the DORA protocol. So this is essentially the messages that are sent in order to receive an IP address. So the client here will first join a network and they'll send out a discover, which is a broadcast. So they're sending that out to everyone on the network. They broadcast and they basically say, hey, all the devices on this network, is there a DHCP server here somewhere? And the DHCP server will receive that. All the other devices ignore it because they know, hey, I'm not a DHCP server. I'm not meant for that. So the DHCP server receives that and they offer an IP address in the form of a unicast. So they'll say, hey man, I'm just going to message you directly. Yes, I have this IP address for you. Absolutely, I can do that for you. Finally, the client responds with a request, which is a broadcast again, because they don't actually have an IP address yet themselves. They're broadcasting that request and they're saying, hey man, can I please have it? And finally, the DHCP server sends an acknowledge, which is saying, yes, that is yours now. And only after that does that client actually have that IP address, all right? Now, if you want to pause and read these notes here specifically, you can, but I'm gonna go ahead and move on because we got some more stuff to cover and you don't want me to read off of my notes all day. Leases. The lease, guys, is essentially just that idea. You just need to know that a DHCP lease is like the DHCP server is here. He might give an IP address of 1.1.1.1, right? And eventually that's going to expire. That will have to be returned. It's not for the device to keep. It has to be returned at some point. Now, there is the idea of a lease renewal, which is like this IP address will expire, but before it does, there's the opportunity to renew. And the device, if it's still active on the network, will attempt to renew the lease with the DHCP server to continue using the same IP address. All right. If it's successful, the lease duration is extended. But just know it's always borrowed, right? It's never there. It's a lease. It is a lease. All right. If the lease expires without a renewal, for example, the device disconnects from the network, the IP address is returned to the pool of available addresses, and then another device over here could potentially take it, and it's a happy guy because it's got an IP address, right? So they're leased out, they're rented, like when you used to go to Blockbuster. Maybe if you did that, you wouldn't buy the movie, you would rent the movie, all right? Now, reservations. This is when basically your device joins and he says, hey man, can I always have the IP address 1.1.1.1, whatever IP address it is? And the DHCP server here is like, yeah man, sure, no worries. What he's going to do is he's going to put that IP address aside, 1.1.1.1, and he's going to say that IP address is reserved for this specific MAC address. So they use the MAC address. Whenever the device with this MAC address joins, I'm going to give them this IP address, and I'm not going to give anyone else that IP address. All right, that's pretty much how they operate, and that is called a DHCP reservation. You're reserving that particular IP address. All right, and it's based on the MAC address. You need to know it's based on the MAC address. Okay, let's go. Scope. So the scope is basically the defined range of IP addresses that a DHCP server can distribute to devices. So you can only give out here, for example, you can only give out 192.168.1.1 to 192.168.1.254. That is all the IP addresses you have, right? So that is it. It also defines the subnet mask that can be given. Okay, it defines what subnet mask can and cannot be given. It defines the duration of the lease. Do they get those IP addresses for 24 hours? Do they get them for 6 hours? It's up to you. That's in the scope. It also sets the default gateway, so the IP address of the router or gateway that devices should use to access other networks. It will define that in the scope, and the DNS servers as well. What DNS servers do we use for domain name resolution on this network too? So the scope contains all that information. The scope is basically like, what IP addresses can we use, and what router do we go to, and what DNS server do we use, right? That's the scope. We also need to know about exclusions. So that's basically like saying, don't ever give anyone these IP addresses. Long story short, you can pause and read this, but it's just like saying, don't ever give anyone these IP addresses. They are excluded. Don't do it or you're in trouble. Now we're on the second last one. We're talking about VLANs, or virtual local area networks. You definitely need to know about this for your exam. I guarantee you there'll almost certainly be a question on this. Now, I'll let you read through those notes soon, but I'm just going to go through the visual example. Let's say you've got a switch. Now remember what a switch is. A switch is you've got all these devices, and these devices are all plugged into the switch, right? When you plug into a switch with an Ethernet cable, for example, you basically connect to that switch, and that switch says, okay, a device with this particular MAC address is connected to this port. So on this port, there is a particular MAC address, right? Now, what a VLAN does is it says, you know what, we're all connected to the same switch, but we've got three different kind of categories of people that work here. Why don't we split them up and just pretend that they're different? Pretend that they're on completely different networks. Yes, we're all physically plugged into the same switch, but what if we just pretended? So what we're going to do is we're going to say, security, you guys are on this virtual local area network, okay? Finance, oops, what am I doing? Finance, you guys are on this particular local area network, and help desk, you guys are on this particular local area network. Now, the reason this is good is because maybe security, finance, and help desk often talk to each other, but they don't necessarily communicate with the other categories that much. Maybe they mostly just talk amongst each other, right? They're just talking to each other a lot. In that case, what this could potentially do is it does a couple of good things. The first thing is it limits the broadcast, which means like if security wants to send out a broadcast to everyone, right? Instead of flooding the entire network over here and doing it to everybody, they're just gonna send a broadcast out only to their virtual local area network. So it reduces unnecessary traffic. It also improves security, right? Because if someone gets into this virtual local area network, ironically enough, let's say they get into the security local area network, they still have to go through a new gateway, right, to get into finance or to get into help desk. They don't immediately get access to all of the networks because there's 3 different networks. So by reducing the broadcast that you're sending, you're also improving the performance of the network, right? Because there's less traffic on there. So that's pretty much what a VLAN is. Again, pause and have a read of this if you really want to get deeper into it. We're going to move on though to our last one, which is VPNs, or virtual private networks. So a VPN, I'm sure you've heard of it before. You've probably seen ads on YouTube for like VPNs that you can buy. They're always sponsoring videos. A VPN is a virtual private network. So it's like a secure tunnel for your internet connection. It's basically a way for you to take your data that you're sending and encrypt it. It's always encrypted. It has a few core functions. A VPN, or virtual private network, encrypts, so they make sure no one else can see your traffic. If they try to hack in and get your traffic, they'll just see random 1s and 0s and it'll be all garbled. They won't be able to see it. It'll be encrypted. Also, privacy. You can actually hide your IP address with a virtual private network as well. Access control too. If you're working from home, for example, oh, actually, that's the next one. This one, sorry, is you can gain access to region-restricted content. So if you want to access the shows available on Netflix in America, but you live in Australia like me, you can use a VPN to change your IP address and make it look like you actually live in America, okay? And finally, a secure connection. So VPNs create a secure connection between your device and the VPN server. So you're protected from hackers, particularly on public Wi-Fi networks. So if you're asked a question like, you're in a cafe and you need to use the public Wi-Fi, which of the best options is one that you can use in order to have secure internet connection? VPN is probably going to be the right answer there, okay? And there's an example scenario there for you too, if you want to have a look at that. But that's pretty much it, guys. We're going to go ahead and move on to the questions. The first question reads, Your organization wants to configure its domain so that incoming emails are routed to its dedicated mail server at mail.example.com. To achieve this, you need to add a DNS record that directs email traffic to the appropriate mail server. Which DNS record is responsible for handling this configuration? A. MX, B. TXT, C. AAAA, or D. A. Your answer coming in 3, 2, 1. Pause the video if you need more time. Here we go. It is MX. So if it's talking about emails at all, it's going to be MX. Pause and read the explanations for the other ones if you want, guys. I'm not going to talk through it all because my voice will be gone for, but that was the answer to that one. Hopefully you got that right. Now, we're going to go ahead and have a look at the next one, which reads, a company wants to protect its email domain from spoofing. To do this, they create a DNS text record that specifies how receiving mail servers should handle emails that fail relevant checks. This record also instructs the servers to send reports back to the domain owner about any potential authentication issues. Which protocol is being described? A. SPF, B. DKIM, C. TXT, D. DMARC. Pause the video if you need more time. Answer coming in 3, 2, 1. It is D. DMARC. Remember DMARC, we talked about that character of Mark with the glasses, kind of like I look like now, decides what happens to emails that fail the SPF or DKIM checklist. We talked about how SPF has that list of approved IP addresses that it compares it to see are you actually allowed to send mail. If not, then you're probably spam and you're just pretending. We also talked about how DKIM uses those keys, a public key and a private key, to make sure it's actually the right person sending that mail. And a text entry is just too vague, long story short, right? It's just too vague. It's like, yeah, it's a type of text record, but it's not the right answer. It's not specific enough. The next question reads, an IT administrator configures the DHCP server so that a device with a known MAC address always receives the IP address 192.168.1.50. This IP address is excluded from the pool of addresses offered to other devices. Every time the server requests an IP via DHCP, it is assigned 192.168.1.50. Is this scenario describing a DHCP reservation? A. Yes, because the DHCP server is configured to always assign the same IP address to the specific device based on its MAC address. B. No, because the IP address is being dynamically assigned through the regular DHCP process without any static binding. C. Yes, because the server's IP is set permanently on the device itself, ensuring it never changes even after lease expiration. Or D. No, because a DHCP reservation would allow multiple devices to cycle through the reserved address rather than fixing it to one device. Pause the video if you need more time. Your answer in 3, 2, 1, and it is yes, A, because the DHCP server is configured to always assign the same IP address to the specific device based on its MAC address. So hopefully we got that one, guys. That one was really just a lot of unnecessary language to try to confuse you. If you're reserving an IP address for a specific MAC address, that is a reservation, 100%. The next question reads, which of the following descriptions best explains the DHCP lease mechanism? A DHCP lease assigns an IP address temporarily without a predefined duration. Actually, you know what, guys? That's too much writing. Just pause the video, have a read. I can't read all that. Swear to God, I'm gonna lose my voice. Pause the video, read it. Your answer's coming in 3, 2, 1. Here we go. The answer is C. A DHCP lease is a temporary rental agreement. When a device requests an IP address, the DHCP server assigns an available address for a specified period. The device can renew the lease before it expires to continue using the same IP address. Otherwise, the IP address is returned to the pool. So basically, guys, you just need to know what a DHCP lease is and how it works. If you've been paying attention to this video, we've covered it and we've covered all you need to know about it. Now, the next one reads, a network administrator configures a DHCP scope that assigns IP addresses from 192.168.1.10 to 192.168.1.254. However, to ensure that critical devices like servers and printers can be configured with fixed IP addresses, she marks the range 192.168.1.50 to 192.168.1.60 to be skipped by the DHCP server during dynamic allocations. When any new device requests an IP address, it will only receive an address outside of this reserved range. Which option best describes this configuration? A. DHCP reservation, B. DHCP exclusion, C. Static IP assignment, or D. DHCP address filtering. Pause the video if you need more time. Your answer coming in 3, 2, 1. Here we go. It is DHCP exclusion because it excluded those addresses. All right. It excluded those addresses. It said that it wants to ensure critical devices like servers and printers can be configured with fixed addresses. So she marked the range to be skipped. So this is all about marking that IP address range to be skipped. All right. So that is what was being described there. Hopefully we got that. That was exclusion. I think, and I hope the final question is, a company has a single physical network connecting all its employees to improve security and network performance. The network administrator logically divides the network into distinct groups for the finance, HR, and IT departments, although all departments share the same wiring and switches. Each group's traffic is isolated from the others, reducing unnecessary broadcast traffic and allowing for tailored security policies. Which network technology is being used in this scenario? A. VPN, B. NAT, C. DKIM, or D. VLAN. I'm going to take a sip of my coffee and then I'll give you your answer. If you need more time, just pause the video. 3, 2, 1, let's go. The answer is VLAN. It's a VLAN. That was describing a virtual local area network. You're using the same physical network, but it's logically divided. That's what we talked about earlier in the video. Now, guys, if you have enjoyed this and you want to see how you're going, you can actually go download my free practice exam. You just click the link in the pinned comment or in the description below. I've got 3 performance-based questions in that exam. I've got multiple choice questions that covers all the exam objectives in the same ratio that they're laid out in the exam objectives. You've also got the option to go and grab a learning guide over at journeytocyber.com. This is what people are saying about the learning guide. They're saying, your notes definitely helped me pass my test today. Thank you. They're saying your learning guide is actually goated. I don't comment a lot, but it definitely helps with organized information and helps me piece things together more easily. And this one I really like, says, I downloaded your learning guide already and I can see it will help me immensely with studying. I tried some other popular resources but struggled absorbing the material. Will you have one available for A+ 1102? Spoiler alert, I do. Now, and this one also says, I just passed 1102 on the first try. You saved me. I don't think they actually bought the learning guide. I think that was just from my free YouTube content. That being said though, guys, this is all based on my old learning guide. For this one, for the 1201, I've taken it and supercharged it. So it's like double as effective as that. So if these guys are passing with it, then I know you'll be able to do the same. So if you want that, journeytocyber.com. Basically what I've done is I have taken everything, broken it down into exact exam objectives, as you can see here. So it's all broken down. For each exam objective, you get multiple choice questions, explicit answers, notes. You can actually have a look at what you get here, multiple choice questions, answers. You also get a whole thing of 11 performance-based questions for the whole exam, and you get notes broken down by exam objectives. All right, so you actually get notes for each and every dot point, for each of all of these, right? So not just every main dot point, but also for every dot point, you've got notes. And the questions cover absolutely everything in the exam. I've made sure of it. You're not going to miss a thing, okay? So it's really been designed to help you study for your exam. You also get a video where I tell you how to use 2 free AI tools to like 10 times your learning. So if you get those topics you just get stuck on, I really show you how to get over that. And I also give you a video showing you how to use multiple choice questions to actually study, because most people, when they use multiple choice questions, they don't really use the right technique, and the reason they fail is because they don't know how. So I run you through a method of studying using multiple choice questions that really will result in your success. And that's all over at journeytocyber.com. All right, I'm done. I'll see you in the next episode, guys.